So this is working okay? Yeah. Good evening. Thank you for coming along, and thank you for the invitation to come and talk at Yandex today. It's very interesting to come and see your laboratories in your offices here and to meet some of you and find out a little about what Yandex in Moscow is doing. The title of the presentation I'm going to make is Multimedia Information Seeking Through Search and Hyperlinking. I wasn't entirely sure how to pitch this, so it's not deeply technical, but it's kind of more focused to understanding user needs and how to evaluate attempts to develop technologies to understand what's required and what the technical challenges are, and then to sort of put data sets in place for people to work with them. If you want to ask some more technical questions about how people have gone about doing the tasks, then I'll kind of attempt to field them, but various people have been participating and working on various things, so I can't give full details of everything people are doing, but do feel free to ask some technical questions. Just an overview of how it's going to work. I'll give some background and some motivation to the activities. These take place within the context of a benchmarking campaign called MediaEval, so I'll give you a little bit of background on MediaEval, those of you who are not familiar with it, and then talk about two particular tasks that we've been working on for the last 2 years. One which is complete, we did last year, one which is probably about 75% complete for this year, so I don't have final results yet, but we have most of the things in place, and then just give you some thoughts on conclusions of what we've learnt so far and where I see this going in the next year or two. And you can hear me okay? I'm not going too fast. This is okay? Yeah? Good. Great. So let's build up from the bottom. So search and hyperlink navigation are well-established ways of searching in the textual web, so Yandex technology, Google technology, Bing technologies. And in parallel with that, we're getting large amounts of multimedia content appearing online. So people are uploading to public video services. Many corporations have got a lot of corporate and enterprise content being developed locally. So we've got lots of technology to capture data, lots of technology to store data, but we have less technology of multimedia data. We have less technology to actually be able to go and search it and find things. So this is, from a researcher's perspective, this is kind of good because there's lots of challenges to try and develop good technologies. It's also challenges to understand what people might actually want, to actually go to users and say, well, if we gave you this, would you use it? Or what kind of things would you like to do? And then think about what that means in terms of technology challenges. So realizing the potential of content requires users to be provided with engaging ways to interact with content. So helping them to discover things, helping them to browse things, helping them to satisfy their needs, helping them to navigate around, see what's related to what else and what else they might like to look at and engage with. But users aren't the same, so what different needs do they have? And if they have different needs, do those propose different technology challenges? So we need to understand what they want. So, for example, media professionals who work for organizations who curate content will have very different ways of working typically than students who will have differences to researchers who maybe have more technical questions and have very particular ways of looking for things, and then just home users who they're probably the largest user group, but they don't have training in how to look for things, and who knows what they will want to look for and how they will want to look for it. We're interested in understanding how different classes of users will want to interact with technologies and the types of needs that they will have. From a technology point of view, we can step back and say, well, what do people currently do in multimedia information retrieval or multimedia search? So a lot of the public content, the public work that's out there is looking for individual relevant items. So I'm thinking here particularly of things like the TrekVid campaign, or the TrekVid benchmarks, which many of you will be familiar with in multimedia and video search. And a lot of TrekVid work, and indeed a lot of work in, say, the computer vision community, the multimedia communities, has focused on things where the information needs are very visual. So they're looking for a visual event in video. And of course, that's a fine thing to do. Many information needs will be very visual, and it creates very many technical challenges. So the kind of visual processing is hard. There's no getting away from it. It's technically demanding. Very good people are working in this. But it does kind of not focus on the sort of multimodal aspects of multimedia content. And then from a purely engineering point of view, some of these people are looking at saying, well, surely videos are related to each other by things that are in them, the events that happen, who's appearing. So you'll get quite a lot of work where people are saying, I want to find examples of this individual appearing in as many videos as possible. And then we'll link these videos together because the same character has appeared in multiple videos. And that's, again, it's a technical challenge. It's very difficult. So you want to look at, say, using contextual features to help, the fact that lots of people look very similar. To actually make this work is hard, but it's not really driven by user needs. Usually when I'm talking to people about this kind of thing, it's quite clear it's being driven by the engineering challenge of doing it, rather than being driven by a real use case. And then we have some examples of genuinely interesting, and I think driven by a potential user needs. Things like taking multimedia content and linking it to explanatory content, textual content. So taking a video, pulling out features, maybe from the dialogue, maybe from what's appearing in visual features, and linking it to things like Wikipedia. So an explanation of who this character is, or an explanation of this historical event or something, so that somebody's watching this, they don't fully understand, they want a bit more kind of background material. And then we have the sort of classic thing we see in a good number of places to do with multimedia content, where we don't really look at the content itself, but we look at how people use it. So social recommendations. So either implied because I clicked on this video, and then I clicked on this video, and then I clicked on this video, and lots of other people did the same. So if you watch this video, you might like this one too. Or explicit, I like this, and I like this. So, we actually know that people like this. And, so I'm not saying any of these things are a bad idea, but this is kind of where things are, and we want to do something that's a little bit different. So we're primarily interested in search and hyperlinking, which aims to explore multimodal aspects of multimedia content, and to link videos to support potential user interests or needs and videos that are related to each other in different ways. So just as a kind of example of the kind of thing we're thinking of, so this would be a kind of a current way of looking at things. This could be good. Yeah, so here we have a video. This is about interesting things in London. And based on a social recommendation, you end up with things that are interesting in New York. Now, they're both big cities, probably they have similar interesting things, but it's not really tied to here, so it's not really based on content. And here we've got Amsterdam. This one is about London. But our way of thinking about this is perhaps we're more interested in something like this. So we've got our video about London, but within this, as someone watches through the video, they might say, well, actually, I'd like to see more examples of that kind of thing. And so this here is kind of food that's available in London, focusing on fish and chips, and so we have some other videos about fish and chips. So if we can identify that there's a particular thing in this part of the video, and then pull out some useful features, we can go search for related videos, and then you're watching this part, think, actually I'd like to see some more videos like that. And we've automatically created some links that you can follow. And we go a bit further through the video, and we have some examples of sort of red telephone boxes, and so we have some videos about red telephone boxes. Now that's, in a sense, it's probably quite an easy one to do because you've got a very obvious object here, and you can try and find that in other videos. But that's the basic idea, to try and sort of go beyond the idea of just recommending videos that might be liked because somebody else liked them, to actually looking at the content and saying, from this video, what else might you want to look at? But of course that poses challenges. Why do you want to look at it, and what sorts of things do you want to look at? And so part of what we're trying to understand is the types of links that people might want to follow, how to extract them initially manually by sort of marking up the content and saying, right, I'd like to have a link from here, and just looking at the challenge of forming that link. And then further on, you might say, well, let's look at the video. I know the kinds of links that people want. Let's see if I can automatically pull them out of the content and then go look for them. So, getting a greater level of automation in the process. So, as I said before, these studies that I'm going to talk about today take place within the context of the MediaEval Multimedia Evaluation Benchmarking Campaign, which you can look at the kind of task that we're looking at the moment at this URL. So this runs a bit like sort of Trek type things with multiple tasks, but I'll just give you a kind of so it's a benchmark initiative focusing on information access and indexing tasks for multimedia content. Established 3 years ago now, it's hard to believe that we're coming up to our 4th workshop. Follows on from earlier work in Clay, where we ran a video processing task for multilingual video. And we're primarily interested in new algorithms for novel and emerging tasks, which are driven by a use case. So the search and hyperlinking task is a kind of classic example in the sense that there are not really established technologies, there are not really established data sets, there are not really established evaluation metrics, but if we talk to content providers, they're very interested in developing technologies of this sort. And MediaEval has a particular focus in looking across different media sources, tasks that integrate audio and speech, visual content, user and automatically created tags, user needs, user participation in tasks, and placing them in context. So in that sense, it's a little bit different to a lot of the benchmarks which don't have such a kind of cross-modal focus. And tasks typically have Trek-style annual cycles, so there'll be a task. Actually, I probably should have had a point up here that we initially have a call for tasks, and we choose the tasks that we want to run for the year. Then we have a call for participation. When participants sign up, we release them data. A little later in the year, they submit their results. We then evaluate their results, and then the participants gather at a workshop to discuss what we've done. So we ran this task last year, building on some earlier work, and we're running it again this year. This is our workshop last year in Pisa in Italy, which we co-located with the European Computer Vision Conference. Not formally, but expressing our kind of, or showing the kind of interest in different communities. So we tend to move the workshop so that it's related to other disciplines. So the previous year it was in the same. It was co-located with the Interspeech Conference, and this year's workshop is actually associated with ACM Multimedia, which is in Barcelona in October. So back to search and hyperlinking. So the scenario here is audio-visual exploration of an archive and looking at video-to-video linking. And from a user perspective, we start from the viewpoint that a user has an information need and they want to go and look in a multimedia archive to satisfy that. And then it assumes that having found some interesting content, you want to see something else. So either serendipitous, you look at it and think, oh yeah, you know, I'm interested in that now. I'd like to know a bit more about something. And we want to kind of have extracted that and give you some links. So in the same way as you're browsing the web, quite often you'll read something and thinking, oh, I'd forgotten about that. Or, yes, I'd like to know a bit more about him or this place or something. So you click on a hyperlink and off you go and you read another page, you read some more. So you just kind of browse and navigate and waste a lot of time. But that's kind of just the way the web is, I suppose. So anyway, or you might do sort of genuinely exploratory, that you're starting in a new topic, you find some relevant content, and then you want to go on and find more to develop your understanding of the subject. So just some definitions of exactly kind of what I'm going to talk about as we go along. So we have our kind of main video. So we're not necessarily interested in all of it, so the video itself can be quite long. And that's one of the features of the content that we're looking at, that it's not little cut-up snippets that are focused on topics. Typically, the content will range between different topics. So actually the segmentation process itself and figuring out which part of the video is relevant is actually very challenging. But you've probably got a smaller subsection, so maybe 10 minutes of the 2 hours is of interest to you. And within that, some aspect of it is of greater interest to you. You want to find out more, or if I suggested something else about it, you would follow the link and watch some more video about it. And we refer to that as the anchor. And so that's typically short, and your thought when you look at the anchor is, oh yeah, I'd like to know more about this for some reason, and understanding the different reasons that you might like to follow the anchor or move beyond the anchor is part of the kind of user study of understanding what the task is. And then we create hyperlinks, and the idea, as I say, is to do this part automatically. And then we refer to the target, which is where we want the hyperlink to go to. You know, so there are relevant targets and there are non-relevant targets. Or put it another way, I the targets are the relevant items, and if I propose a link to something which you don't want to see, then my algorithm has failed. And so the research challenge here is to form links to the targets that you're going to say are relevant. And these can be typically shorter set excerpts, again, from within longer videos. So just saying, go to this 2-hour video isn't enough for us. Really, we want to go to a 5-minute section within the video. And so diagrammatically, just to sort of highlight a few features of this is kind of the whole scenario of the task. So we have a search subtask and we have a hyperlinking subtask. And we set it up so there's a known item. So from a research challenge, from a data set point of view, there is a particular item we've identified that we want to find. And we have a query that we give you, which is designed to find this item. And our relevant item is somewhere within this longer video. So this can be cut up either into shots or using some semantic text level segmentation algorithm. But the user has looked at this and said this part here is relevant to the query. And so having established this relevant region within this, there's a part that we've said, right, this is the anchor point. This is the anchor section from which is based either on a visual feature or a spoken feature or some combination of them. And we're not just interested in, from a search point of view, we don't just want to find this video, and we don't just want to necessarily just find one of these relevant segments. We actually want to know where the user would want to start listening or where they would want to start watching. So we refer to this as the jump-in point. So a lot of speech retrieval work and video retrieval work would cut your video, say, into shots and say this is a relevant shot and this is a relevant shot and this is a relevant shot. And they just look at the ranking of those shots and how effectively. We actually want to say, not just have you found the relevant stuff, but where do you actually think the person should start watching? How far away from this ideal jump-in point is your system telling you should start watching the video? Anyway, so that's kind of the search challenge. And then the linking challenge is to say, well, okay, so I've got this anchor point. Let's go out, look within the collection, and see if I can find some targets that people would actually want to link to. And so you've got to segment the content somehow. Again, you can use visual features, you can use textual features, you could use some non-verbal audio features if you want to, some combination of them, cut them into search units, and then form a link to them. And at the moment, we're just saying, is the target relevant? I mean, at a more subtle level, we could say, where do you actually want to start playback of the target? But I mean, that's a step beyond where we are at the moment. So just a summary of the two tasks. So in 2012, we did a known item search across a Creative Commons set called Blip TV, which I'll tell you a little bit more about. And then we wanted to link from our known item, relevant items, to other items from within the collection. So here we weren't doing this more subtle trying to find an anchor within the relevant item. We were just saying, let's link from the relevant item. But we know that that's a kind of a bit of a gross approximation to what we want to do. And so this year, not only have we we're working with the BBC, they provided us with some content which we can actually work with, but we're actually looking. We're actually looking at user-defined anchors within pieces or segments of relevant or interesting video to try to find relevant targets for our linking task. So, and again, I'm going to talk more about how we've set this up and how we've actually used real pseudo users at the BBC to do this. So just running through this. So multimodal search where relevance can be both visual and or in the audio stream. So being multimodal. And so this models a scenario where a user seeks a single relevant item, known item of multimedia content. So you've seen this before, or you know it's there, and you want to go find this one particular item. And once the relevant item has been located, the user can then engage in browsing or exploratory behavior to follow automatically created links to other content they might find interesting within the same collection. The Blip TV set was crawled as part of a European project called Multimedia. Had about 15,000 Creative Commons videos, about 3,200 hours of data, which we divided into a training set and a test set. And we provided to participants, as well as the video, we provided automatically created shot boundaries, so where the camera changes across the video. Then for each shot, we automatically extracted a single keyframe that they could use. And then we used a visual concept detector with, where did the number 589 come from? We're looking for sort of common features across the data set, or across a different data set, actually. And this actually used as a visual detector system developed at the University of Oxford in the UK, which is actually builds dynamic classifiers. So unlike a lot of work on visual concept detectors where you have to build a training set for each detector, this builds a training set on the fly. It's not as accurate as the traditional methods, but it is much more flexible. But this is a relatively large number of visual concepts and focused on the data set. We also had 2 automatically created speech transcripts, one by LIMSI and one by another University of Lyon. And for the main experimental study we did, we actually focused just on English language data. So a certain amount of the content, around, well, getting on towards half of it, is actually in different languages, and it's much easier if we just concentrate on a single language for the purpose of this exercise. So that was the actual data. How did we actually generate our query set for our known items and our anchors for the linking task? So we generated a total of 30 textual queries. 2 different versions, a natural language style one and one which is more like a short web search style query. And these were generated using crowdsourcing, using Amazon Mechanical Turk. And then we added some multimodal features. So we would look at them afterwards and say, oh yeah, we could have these visual features, these things are appearing, and we and how did we generate, or how did we select the videos to show them? Well, we looked at the most popular categories and then randomly selected videos from that. So somebody would apply to do one of our tasks. We would show them, we would say select a video, or the system would automatically select a video, and then we would ask them to do the following things. So the first thing to do is to look at the video, find something that they find interesting in the video, and then mark the beginning and the end points of the interesting content, to transcribe the spoken words in that section accurately, so at least that part of the video we've got a perfect transcription, and then to create the 2 queries on the basis that if you wanted to find this piece of video again, what would you put into the search engine as a long query and a short query for it. So this gives us our queries for our data set, our test set, and we also know what the relevant items are, the relevant known items, and exactly where they are. And those provide us with the, if you like, gold standard points to link from for our linking activity. And how did we evaluate this? Just to kind of run through this. So if we had multiple items, we would use standard average precision, but because we've only got a single item, it's effectively a one-off with sort of mean reciprocal rank of the relevant item. And that's obviously trivial, but just to show you the other metrics we used. So the other one is the generalized average precision, where we punish you not in terms of how far away do you say we should start playback from our ideal point. So not only can you rank, not only where do you rank the relevant item, but where are you recommending that we start playback. So if you pull back the whole, the whole video, you haven't segmented it all, it can be at rank 1. But if your playback point is too far away from where we say the user or the listener or the watcher will be happy to watch from, we score you 0. So you've got to think about not just the ranking, but you've got to think about where you should start playback as well. And we also looked at another metric which we actually developed ourselves, which we refer to as the average segment precision. So here we're interested not just in the rank of where you put the relevant item, but how much of the item that you provide to us is relevant. So by segment precision, we look at a particular segment that's automatically extracted from the video and say what fraction of that segment is actually relevant. So you can provide us with really long segments, but the segment precision will typically be very low there. And if your segment precision is pretty low, then you'll probably have a problem with the generalized average precision as well, because chances are your playback point will be in the wrong place as well. Now, one of the things that these metrics highlight to us is the difficulty of evaluating this. Actually, so as I say, we developed the segment precision metric ourselves, and a similar related one, which actually combines the gap. The gap and the ASP. But none of them quite express the user experience or represent the user experience, and so we're still working to try to come up with better ways of automatically evaluating this. So I should just a few words of kind of the sorts of results we found. So we had about, I think, 5 groups participated in this task last year. They segmented the content in different ways. So some of them would use fixed length windows across the audio content and have them overlapping sliding windows. Other groups were looking at automatic segmentation algorithms based on things like text tiling. Those of you come across that, or some other text-driven segmentation methods. Sometimes using audio features as well. So silence points in the audio soundtrack would be a significant point to introduce a boundary. Some people would be using just visual shots, so running a shot, taking the shot boundaries and using those as their segments. And then looking to rank the content based on the different segments. And so some of the findings from that were things like, if your word error rate in your recognition is low, then short segments are good, because it can be a good match between the segment and the query. If, on the other hand, the word error rate is high, then typically longer segments are good because you need more content in order to be able to get any match with the query at all. Similarly, if the word error rate is bad, combining it with any textual metadata that's provided is a good thing, because you're getting extra words or extra labels into the content. So these things are, in some senses, obvious, but if you think about it, but they at least can kind of confirm intuitively the right things. But it also means that different content different relevant items are achieved or retrieved most effectively using slightly different techniques, depending, I say, things like how well articulated they were, so how well the recognizer is going to work with them. So this kind of poses a challenge of how we can actually come up with a system which works best for all content, or how best to go about doing that. So looking at the hyperlinking, well, we're less ambitious with our way of evaluating this. We just use standard map. So we would, take your link, and someone would, or the groups would then rank what they thought were the best or the most likely links to put together. We took the top 10 of every set of proposed links from the participants and had those evaluated for relevance, generating a separate QREL or relevance file for each of the runs, and also generating a pooled file together. We had this done by Turkers, so we would show them the starting video, we would show them the proposed relevant video and say, what's the relationship between these? And asking roughly these 4 questions. So these videos are totally, or these segments are totally unrelated. These videos are kind of on the same topic, but they're really telling us different things about it. These videos are on the same topic, and they're talking about different perspectives or views on the same information, or these things are all the same, or effectively the same. And for the purposes of what we were doing, we said that any of the lower 3 were counted as relevant. So we were quite generous with our criteria of relevance. And I guess one thing to note here is that we haven't really, at this point, defined why someone's interested in things. So we're just saying, are they related? So it's very exploratory. There aren't points of reference that we can go to in the literature to compare to what other people have done. And so some of the results here were things like that if you use textual search of some sort, then you'll get more similar results than if you use visual features. So one group in particular focused very much on looking at visual similarity. And their results are pretty much totally different to the people who were using the output of the speech recognition system and the metadata. And that's, again, to be expected. But one of the things that's perhaps less to be expected was if we take our pooled set of relevant documents or relevant segments, relevant links, the visual system did the worst. But if you just took its own set of relevant data, it did really well by comparison. So they're kind of looking for different things. One set of relevant are relevant or related visually. And so, this kind of creates a challenge because we really need to understand what kinds of links we're looking for. So we can't say, on one hand, visual features are bad because we haven't really sufficiently defined the task. So as I say, this was very exploratory last year to kind of understand the issues, and we did learn an awful lot from it. So this year's task. So this year we're using 270 hours of BBC archival footage. Now this is just basically a 1 week section of BBC data, so it's not sort of random material gathered over a long period. It's a sort of focused material, material that's owned by the BBC. So for example, some of the content that they broadcast and you would think of as BBC content isn't actually owned by the BBC. 270 hours by some measures is a lot of data, but from a search point of view is trivial. But it's a kind of a start, and it's also we want to kind of understand the kinds of things that people want to do with it. So we need to show it to real people. Well, people who aren't Turkish, people who fit one of our potential user groups. So this year we decided to look at the potential needs of home users. And one of the intuitions is that these people would typically favor exploratory search where they're not entering detailed queries. So compared to the media professional who really understands the data, or the researcher who really understands the domain, the home user is possibly more likely to just click on show me more like this, or show me stuff that's related to this for this reason. And so we think the linking would be of more interest probably to the home user than to some other users. So instead of making our queries in an Amazon Turking environment, this year the queries are being made by potential public users with computer and online experience. So the way the BBC recruits people to do this kind of thing is through an external agency, and people come along, they have to fit a certain profile, they're paid a little bit of money for their time, and the people who were recruited were all UK nationals in a 16 to 30 age group, and they all had high familiarity with computers or computing in general and online activities. So if you want to learn about different groups, obviously you recruit people with different profiles, but they wanted a fairly homogeneous group to be able to at least establish something here. And I'll just run through the procedure, and then I'll show you diagrammatically a little bit more about what they were doing. So they were given a general introduction to video processing or video search using a system called Axes Pro, which you've probably seen the little logo I have here. This thing called Axes, which is an EU project where we're developing a video search system. So we have a current version of our video search system called Axes Pro, which is so Axes sort of professional environment. Which is the one version the BBC are using. So the scope and the type of the collection was explained to these people when they came in, and the users were allowed to explore the collection of it. So have a look around, what kind of content is in there, what stories are being covered. And then the user can use test queries or express some queries to go find a particular thing that they've seen or a particular topic that they're interested in that they know should be in the archive based on what they've found out about the archive. So they look for the relevant video, reformulating their query as they go along to try and find that video, and so hopefully eventually they'll find what they're looking for. So we know what query got them there, and we know what they've indicated as relevant. And then we ask them to identify one or more specific anchors within that video that they've found interesting, based on, and then to specify either whether it's just the region they're interested in, or certain words, or certain visual features, or some combination. So they indicate that. And then they have to explain their reasons for why they wanted to use that anchor to link to something. So we have some sense of what's going to be relevant. So just to look at this a little more diagrammatically, here we have our BBC archive, we have the Axes search system, and then they have to, so we show them some potentially interesting videos, and they find an interesting video. Whoops, we gone? No, okay. So this is the Axes interface, so they type in a query and they get a ranked set of videos, and they get shown various things about them. So whereabouts in a video overall is this particular shot that they're looking at, and they can start playback until they find what they were looking for. So having found their potential interesting video, they look within it for an interesting clip within the longer video, and they specify their clip that they want to link from. And then, so interesting, whoops, hit the wrong thing. So they've found their interesting video. Within it, they found an interesting clip, and then they want to specify the segment that they want to link from. And then when we come to this, we ask them to say, to give us various details. You know, where does the region of interest begin? Where does it end? We want to describe the anchor, describe what they were looking for in the target, and they specify exactly whereabouts in the video their anchor is. So they're defining the query, they're defining the relevant document or the relevant segment, and within that they're defining a clip which they want to treat as an anchor for search purposes. And they're telling us why they want to use that as an anchor. So just a little bit of analysis. So unsurprisingly, perhaps most of the clips that they selected were documentaries and some comedy and some sports, and then some others with less popularity. And then the classification of the different types of anchors. So the most popular here was to look at the whole scene. In general, if it wasn't the whole scene, then it was based on the audio, and then so objects, moving objects and static objects. So perhaps surprising, interesting to find out why they weren't linking from visual content, but in terms of the fact that they're very interested in spoken content, it does kind of, I think it justifies our interest in the spoken and multimodal dimension of video content, where most video search or multimedia search work is really focused in this area over here, where potentially a lot of the time users are not so interested. So how was this set up? So we have 50, from our 30 people, our 30 participants, we selected 50 known item experimental queries. From within those, we then selected 100 anchors, experimental anchors to use in our data set. Run submissions came in the 10th of September, so just a couple of days ago. Right now the relevance assessment of links is ongoing, using returning test volunteers back to the BBC. So they specified the anchors before. We're now saying, remember those anchors you specified, are these potential targets relevant? And because there's a small number of them and we can only get them to do a certain amount of assessment, we're also turning it over to Amazon Mechanical Turk as well to try and get more relevance assessments so that we've got a more meaningful set of relevance data for evaluation. The way these things work, we've got a relatively limited time window of 2 or 3 weeks to do as much relevance assessment as we can. And so planning that's actually proven quite a challenge to actually figure out exactly which parts of which runs we're going to get assessed. And then we'll return the results, and we're going to talk about them at the workshop in about 6 weeks' time. So I can't give you the kind of results of this yet because we haven't got the relevance data. So I'll just conclude with some thoughts. So search is clearly a much more established task than our linking. But little effort in search has really focused on looking at finding reliable jump-in points. So it's most of what other people have done is about ranking relevant items. Most of what our participants have done is about ranking relevant items. We're evaluating them using jump-in points, but if we actually look at the technology of what they've been doing, they haven't really been focusing on that. They're still looking at the challenge of segmentation and ranking. So promising results from the search and hyperlinking task in 2012 encouraged us to move to user studies with BBC data. So we felt we'd understood enough about the task to actually start asking users what they really wanted, and also because we had the possibility of having access to BBC data, to look at the kind of data that general home users are much more likely to work with. Our work so far with the volunteer subjects suggests that people will make use of these links. So when we've explained the operational scenario, you type a query, you get some links, would you make use of this? They understand what we're doing and what we're trying to do, and they're also saying, yes, I would actually make use of this if you offered us this facility. And so the results, direct numerical results, but other findings in terms of feedback from users are helping us to develop our research agenda for this, particularly with a view to refining the task for 2014, but also looking forward to the sorts of different research activities that are necessary in order to develop this field further. And then finally, I should thank my co-coordinators of this task, Robin Alley, Maria Eskovich, and Roland Orderman, and we have funding from various external agencies. Okay, thank you. And if you have any questions or comments or...
Thanks, Gareth. I have a few questions, and the first question is, because you have this group of controlled users at BBC, so did you consider that you can also record their actions and to organize some context-aware retrieval task, something like that?
You mean the guys who are working at the BBC?
Yeah.
So which particular things are you thinking of?
Well, you can, for instance, you can record the first part of their session and then ask. Yeah,
I have to say I'm not sure. I mean, I think the Axis system can actually log everything that people were doing, but I have to say I don't know the answer to your question. I mean, I would like to think they have got more stuff stored away than we've actually used in the task, but I don't know for sure.
Yeah, it would be interesting. And also, for the hyperlinking task, you mentioned that you used MAP, so as I understood, you used binary judgments.
Yes, yes.
But you asked so many questions, so you asked your Turkers, I guess, so many questions that you could also do some graded assessments, right?
Yeah. So we asked them these. So last year we were asking them these questions, and I think we're asking them similar questions again this year. So, these things are either completely unrelated, or they're totally the same thing, or they have some looser relationship. As I say, last year we just took that if they had any relationship at all, they were relevant. But yeah, I mean, clearly we could draw the line further down and say, they've got to be the same before they're related. Or
so judgments now will be graded, or it's still binary?
Yeah, this is just binary at the moment. Okay. Yeah.
And I also wonder, because you have this only 5 participants in the task, so how do you consider how reusable the collection is?
So say again, sorry.
So how reusable the collection is? So if you have only 5 participants, so how do you sort of what do you think? What the quality of the pools?
So that's a good question. So in fact, actually, we actually had a sort of post-workshop collaboration where we basically ran everything again, and we did a lot of reassessment. So I think what we have now is more reusable because we made sure that everyone was exactly on the same page in terms of what they were trying to do as a task. But it's probably still not ideal. I mean, I think the search task is better established than the linking task. I mean, the linking one is, as I say, is very exploratory. I mean, I don't think, we couldn't really draw many conclusions, and I don't know that anyone else would want to draw any definitive conclusions from it either, really. So it's really kind of, what's difficult, what's easy, how do things compare, those kind of general observations. I think the numbers that come out, I don't think are very meaningful.
Thank you.
Questions?
Oh, sorry. Just
Can we look back on ASP definition formula?
Oh, yeah. Okay, yes.
Yeah, there is a segment precision, and what is the definition of that?
Oh, so the SP is a segment precision. So it's
segment precision.
Yeah,
yes.
yeah. So given that it's a piece of video, for example. So if the video is 30 seconds long, so only 20 seconds of it might be regarded as relevant. So the relevance assessor has actually looked, or the person who defined it as a relevant segment has actually looked across the whole video and said the relevant part starts here and the relevant part ends here. And when someone has automatically segmented it, they probably chopped that real relevant region into multiple pieces. And so the actual items you're using for retrieval, what fraction of the item is actually relevant?
Is one of these two? I mean, one of these two numbers generated automatically, and another one is set by assessor, right?
Sorry, I missed that.
I mean, segment precision is generated automatically, and rel of segment precision is.
Oh yeah,
yeah.
No, in fact, they're both kind of manually done. So one of them is saying this segment is relevant. The segment itself is regarded as relevant because it contains some relevant content, and we're then saying what fraction of the segment is relevant. So if you like, the basic version is standard AP. That if it's got some relevant content in it, we're saying it's relevant, and we're then kind of augmenting that to say what fraction of that item is actually relevant.
It's about length of fragment, right?
Yes. Well, not just about length; it's about fraction. So it can be very long and 100% right. Yeah.
No questions more? I have nothing to add. Thank you very much for our talk. Okay. Thank you. We should thank our speaker.